Hello everyone, my name is Rajesh Kumar and I'm your DevOps SRE DevSecOps coach. I have close to 18 plus years of experience working in multiple MNSEs around the globe and having in-depth knowledge of DevOps, SRE and DevSecOps. So I would like to introduce you one certification program in a DevOps, and that is we call it DevOps Certified Professional. Now this is a 2 months of program, 25 tools of DevOps you will learn, and apart from that you will also get the access to the LMS, lifetime access to the videos portal. It's a certification program, and you will have 25 assignments and 2 projects along with it. It's a completely weekend program, so here you have classes on Saturday and Sunday. So as part of this course, you will learn multiple things. Here you see that you will learn Linux, AWS, Docker, Jira, Confluence, Python, Git with GitHub, SonarQube, Maven, Gradle, Packer, Artifactory, Selenium, JMeter, Ansible, Kubernetes, Helm, Terraform, Jenkins, Datadog, Splunk, and Neuralink. Now, how do we, apply for this? So how can you reach out to us? So you have a WhatsApp number and email ID. So please reach out to us, and we'll help you to onboard this program. Apart from this DevOps certified professional programs, we are offering other certifications as well in a DevSecOps, SRE, and one of the very comprehensive programs which we have is in Master in DevOps Engineering. Yeah, so feel free to get in touch with us and then enroll for it. Thank you. We have one session pending on AWS that we'll do later. So let's have a one fresh topic today, and that is Docker. Okay, so the first question which you all of you have in mind, and that is called, what is Docker? So we say Docker is a container management tool, right? Tool, you can call it a platform also, it's up to you. Context required for it. So here when we say Docker is a tool platform, so of course if you're learning new tools today, so of course it should save time, correct? That is the one thing. Save cost also, and then improve quality of the work, right? Because if you are learning something new, uh, that should be the case, right? Simple. So I want to understand that how it can save time, how it can save cost, and how it can improve quality. So I'll put it in this way. If you want to run applications in a physical server, let's say it will take 1 hour, then we migrated to virtual server, AWS or VM and all kind of things, VirtualBox and all. So it started taking 5 minutes, and now using Docker, if you run application in a container, okay, then it will take 1 second. So, so all of you understood that is save time. If you want to run Jenkins, 1 second. If you want to run Jira, 1 second. If you want to run Ubuntu, 1 second. If you want to run Python, 1 second. Any software you want to run, it will run in 1 second. So saving time. So of course you should learn, right? All of you. Correct now? What do you think? Hello? Yeah, I'm audible, right?
Yeah, Rajesh.
Yeah,
Yeah. Okay.
Any application we can start in the virtual also, like within 5 minutes, right? Even 1 minute or something, just like dot slash any application. Right? It's like how come
Huh.
it's slow? The difference.
Huh. So here when I say applications in VM, uh, you create a VM and then applications is running, right? So on an average, I'm saying it can take 2-3 minutes also. But here compared to 2-3 minutes, 180 seconds versus 1 second. That's the difference I want. Correct now?
Okay. Yeah.
So second thing is cost. Cost means what? When you run applications, where you spend cost. So when you run application, you required CPU cost, you required RAM cost, you required hard disk cost, you have to pay operating system cost as well, right? These are the cost. And on top of that, you have to run application in data center. A data center means, you know that WhatsApp is been running in data center, LinkedIn, Twitter, Amazon.com, Flipkart.com. All this runs in the data centers. To manage a data center, you need a premises, electricity, salaries to the employees, and all a lot of cost. So I'm putting at a high level. Okay, don't uh, think too much. At a high level, let's say 10 applications I'm running at 100 rupees with the physical server. Here I'm running 10 applications with 50 rupees in virtual server. Virtual server is there from last 20 years. In fact, I taught you last time also. Same application, number of application 50 rupees. I'm just giving you this way to understand. 10 applications you are running in 10 rupees. So tell me any one region we should not migrate to containers. Correct. So you are saving time. You are saving, what do you think? Cost. And then on top of that, quality of the software. So see, if I save, let's say you say, Rajesh, I spend half of the time out of 8 hours spending on setting up the infrastructure for dev environment, QA environment, integration, this, that, and all. And next moment I say, hey, I can save all this cost, time. So if I'm saving your time and cost both, then the time which you save, you can spend on to write a good quality code or good quality testing, right? I hope you remember the discussion on DevOps. Everyone are supposed to write a code, and they will write a code in what, that is up to their profile and responsibility. So yes, you will write a good quality code, actually good quality testings, so overall it will be improving. Are you understanding, all of you?
Yes.
Yeah. So reasons you got it, why should you migrate from VMs to container? If say, someone will say, you can answer this, but still I don't understand what is container. So that I will come back to this. But before that, management. What is management? So management means what? So container management. So earlier I taught you VM management. So VM management was done by what? VirtualBox, Vagrant, VMware, AWS, Azure, Google Cloud. They are doing nothing but a VM management, right? They're managing the virtual machines. So here, when we do the management of the container, what management you are talking about? So just like that, you create a VM. So same way, create a container. So management. Stop the container. Sorry, start first, no? Then stop. You stop, then restart, or start again back. Start and then restart container. See, created the container, then started the container, then stopped the container, then again started the container, again restarted the container. Okay. Kill the container. No, let's make it pause the container. Pause, unpause, unpause, and kill and remove. So this is called management. Same thing you did on AWS last day. Same thing you did on VirtualBox last day. Same thing you did with Vagrant also last day. If you're Azure user, you will do the same thing. You create a VM, start the VM, stop the VM, start the VM, restart the VM, pause the VM, unpause the VM, kill the VM, and remove the VM. So same way you can create a container, start the container, stop the container, restart the container, pause the container, unpause, kill, and remove using Docker. So understood that Docker can do. If someone will ask you what Docker can do, so you can say Docker manage a container. Then he will ask you, I'm not able to understand what management you're talking about. So simplify this. Say that Docker can create a container. Start, stop, restart, pause, unpause, kill and remove. So we have understood why we are using Docker in a simple way, and then why that Docker is managing a container. How is managing. So clear, all of you? Hello.
Yeah, Rajesh.
The now most important question is container. What is container? This is the most important question. Now, guys, you know what? Typically, this discussion, what is container, can take longer actually. It may take more than 2 hours, but that's not, I'm going to do that. First thing is, you will lose the interest learning some topics. And second thing, if in fact, lots of, you know, uh, energy I'll put without any benefit, like you will not hear me anything. Just ignore all these things. So in order to understand the containers, we need to know Linux internal. Okay, internal, Linux internal. Then you have to ask a question. Forget about the container. I'm not talking about the container. I'm talking about Linux or Windows. Go inside that. Go back to the basics, semester one. If you studied in engineering college in India at least, then go to back to semester one. And same thing you have to study now then. Linux internal, Windows internal. What this question is very important. What are the resources? What are the resources we need to run any applications? This is a very simple question, but it has a huge detail actually. Okay, huge detail. So right now I will not get into the too depth, but this recording is available in LMS. I did 5 days of Docker session for some batch, 40-hour session I guess, only for Docker, and in that I discuss about that one. So if someone is finding interest, okay, you can go ahead it. But let's say if you are a little bit scared from the technology, you don't have a time, or maybe you just want to learn faster, then this is the right session for you. Okay, so this question is very important. I would like you to get into that. For that, you have to deep dive into the Linux container. But because I need to tell you something so you can get started. So what is container? So in order to explain you the container, I'll have to give you the picturization. So you'll understand that, but you have to practice to explain to someone else. Okay. Here, if the question was, what are the resources we need to run applications? So first thing I need is hardware. One more thing, whenever you get confused, please stop and ask a question. Okay, that's good practice. So this is the hardware. And after that, you'll say, Rajesh, we need a software. So this is a software operating system. And then operating system, we have a kernel. All of you know that. I think we did discuss Linux. Linux sessions, we had it, right? OS, I did discuss, correct? All of you? Correct?
Yeah, yeah, yes, yeah.
Yeah. So Linux kernel, nothing great about it. You know, kernel is a code. Okay, mind it. Don't get confused. Kernel is not hardware. OS is not a hardware. It's a software. It's a code. This code is written in C language. Okay. So kernel, I'll put it in a very simple way. Kernel create one mount. Now you will say, Rajesh, what is mount? I'll put it in a simple way. Kernel create your root file system. What is a root file system? So sometime I'm calling mount, sometime I'm calling root file system. What exactly that is? So for that, I'll just go for root file system, Google it, and put it in images, and do let me know if you have seen this somewhere or not. If you have not seen this, then I think you're wasting time in this batch. If you have seen this, then it's good. Have anyone have seen this?
Yes.
Yeah, everyone have seen this. Okay, maybe some of you are scared from Linux. So at least you love Windows, right? Let's go to Windows. Where's my PC? After upgrading to 11, Windows 11, I'm getting lots of issues actually. It's very difficult to you this. Just a second. So have you seen this one, all of you? This one, and then this one. Of course, you must be laughing. Everyone have seen this. What we call it? Have you ever tried to know that? So this is called Windows root file system, and this is called Linux root file system. Okay. So different file systems we have. So this is a system file system. We call it root file system. Do you want to see user file system? Let me show you. Here it is a user file system. This will be shown only to Rajesh Kumar. Okay. You want to see application file system? Let me show you some application. Usually I install all of my applications in C drives. Okay. C tools. This is a JMeter file system, application file system. So what I was trying to tell you, every time when you go and create a operating system, one you get a one file system which is a root file system. In Windows we have C drive, D drive, and in Linux we have OPT and dub. Clear all of you? Questions?
No, Rajesh.
Okay. So now you get one more thing which you get it, Petri. Okay, these all come from the kernel. Okay, mind it, Petri.
What is the
So
command
now
you
you
issued, Rajesh, for finding this the Windows applications? TART, something you
P,
issued the
PC, my
PC.
PC, this PC. I mean, slowly that Windows operating system also getting migrated into app based actually.
Okay.
So I'm from the old school, so sometimes I feel little irritation actually. Yeah. So this is a root file system, and then here we have Petri. Petri. Now you'll say, what is Petri? So here you get one Petri, one Petri. How many root file system you get it? One. Okay, mind it. Mm, Here means one C drive. In simple way, I'm putting up. Have you seen the multiple C drive? No, only one C drive. One Petri means what? Petri means it create a process table, because you know, remember that each application you run, it required the PID ID to gain the CPU and RAM, right? So the process tree has to create it. Okay, process tree. So for example, if you see that it'll put it in this way. uh, this first, see, everything comes from nothing. Okay. If you have read some uh, you know um, some what do you say, spiritual books, something like a Gita and all, so it's true actually. So everything come from nothing, which is zero. Okay. And here you want to see that task manager, see that here. uh, See here, this is the nothing. This is a source for everything, which is nothing. No, not a thing. Nothing means not like says it's not something which you can't. Nothing means it's something which you can't understand. Okay, can't understand. Nothing means not a thing, because we also always identify a thing, right? So it's not a thing. So see here. So everything comes from the nothing, which is non-zero. From zero, then we got one. This is important, guys. Okay, first process. In Linux, it's a one. Okay, let me show you in Linux also parallelly. Use -f. Here, look at this. And this come from the parent is zero. Correct now? And in Windows, a little bit one and two has been utilized and cleared also. So fourth is one process. First PID is fourth one actually. So right now one, this is your operating system get loaded, and then from here some new few process will be loaded, but I'm not talking about. So this has been logged in by Raj, and this is Jamie. Okay, so here this is Raj, this is Jamie, this is the process, let's say 3, and this is a 4 process. Now Raj has decided to run Apache, so he'll become a 5, and Jamie has decided to run Tomcat, and this will become a 6. 6, right? Yeah, 6. This is 5. So this is called Petri. So you see that here, all this Petri, you look at this here, and then in Linux also you see that this is the Petri. So how many one what Petri you get it in each operating system? One. So one root file system you get it from what do you say, kernel. One Petri you get it, and then one more thing you get it. Though there are so many things you get it from the kernel, I'm not complicating the discussion. One more thing you get it, which is called networking. Why do we need a networking? Anyone have idea? Why need a networking?
To accessible by the users in the network.
Other people, right? Accessible, because if you want to access the console, there's no networking required. But if you want that to be accessible by others, then one network at least you need it. So here I'll show you my network actually. Keep showing so you'll understand this, others you'll not understand the context. If config, this is my laptop, okay? And this is the network which I'm connected to here. I'm connected to Wi-Fi right now, home Wi-Fi. So this is one network, you get it. This is my IP address. Okay, so here I got this hardware. So what was the question actually? I forgot. The question was, what are the resources we need to run application? So anyone will tell it's not a great question because everyone knows that we need a hardware, then we need an operating system. Operating system has kernel. Kernel has a namespace. Namespace will create. These are the resources: root file system, Petri, and network. What is a namespace? I did not talk, as I said, I am not complicating the discussion, but if you study the kernel, you will have a better knowledge. So kernel namespaces, look at this. This is the official image. I think this is the best image. Little old, but it's okay. This is the one. So, see that. This is the Linux kernel. You have a C groups. Now, what is C groups? Let's try to find out. Namespace. What is namespace? Try to find out. SE Linux, capability, app armor, net filter, netlink. So these are the resources we have in the kernel. The same kernel which I was talking about here. And these are the resources which you see is network, Petri, root file system. All this come from the namespaces. Okay, so I'm ignoring those topics because it will be too much. So this is the one. So far so good. All of you understood this? All
Yeah.
of you?
Yeah.
Okay. Now the
Yes.
question is, question is, see, I will ask a question. What are the resources we need to run app? Where is app? So guys, look at my table. I want you to focus on it. This is the one which is, I think many of you were ignoring it, but you'll have to know now. You have to go to the basic. Now, this is the one. See that these are so many applications running. These all are applications, okay? Mind it, these all are applications. And each of this application associated with the PID ID. And the PID is unique, always incremental also. Okay. And now this PID, you see that CPU is getting aligned to the process ID, and the RAM also getting aligned to the all process ID. If you look at it. Let me tell you here, any processes you see which you have run without a user, see, there's no empty. So that means you cannot run application, no matter what applications, without a user, without a PID, without a CPU, without a RAM. Agree with me? See, this is running, all are running. Let me show you the table. See that. Scroll down and see that I have not started my machine, restarted my machine from last night. So many applications running. So yes, you need to, the question was, what are the resources you need to run? So you need one more thing which is called user. So where is that? So let me create a user. This is Raju, this is Jamie, and this is Priya. Raju user, Jamie user, Priya user. They all log into the same hardware operating system. So Raju is doing what? So Raju has run applications called Apache. By the way, anyone would like to tell me what is the port number for Apache? Default port?
800.
8080.
80, only 80, yeah. And if you run this application Apache, some PID will be there. Let's say 50 PID. And where is been writing the Apache? See, my favorite location, I told you C tools, but here it can be OPT Apache if it is Linux. Can be. Okay, done. So now mind it here, there is a three users, one user, two user, three user. And if you look at it architecture, all three users are using same network, same Petri, same root file system, and kernel and so on. That means this resources it's common for all three users. That is a consideration. So now Jamie would like to run Apache again. So Jamie will be able to run Apache. Tell me yes or no.
Yes, but different application. Oh, sorry, different
Different.
ports. Port.
That's a problem. That is a problem here. Priya will also like to run Apache here, and she'll not be able to run it because port number is already occupied. Why? Because there's only one network. Now let's say Jamie will write a C Apache. Is it a good practice? Sorry, OPT Apache, no? OPT Apache is Linux, yeah. OPT Apache. Is it a good practice? Data will be compromised. Rajesh data will be compromised with Jamie data, correct? Na? This is not a good
Yes.
way. And
Yeah.
whether he'll be also having 50 PID, no, maybe 51 and 52. So there is a problem here. Theoretically, if you change the port number and locations, you can run this application. But who is doing all this work in a data center? No one. In data center, we want the consistency. That means every Apache should run 80 port, every Apache should write OPT Apache, and every Apache should be, what do you say, should be having 50 PID. Correct, no? Consistency we want. Why? Because load balancer will not work. So, this is the problem. So theoretically it was allowed to run, user can run the Apache, but it was not possible. So what, 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 what this one did, virtualization technology, they did what, so look at this. They did what? They have a hardware and then they have a hypervisor on top of it. Okay, so this is the hardware. Hypervisor means what? Hypervisor means
Which will,
VMware.
yeah, VMware. Yeah.
VM. And then we hypervisor create a VM here. VM number one, VM number two, VM number three. And in the each VM, you got kernel here, OS kernel, kernel. And then here you get one network, one root file system, one PID tree, and one user, and then applications running. Same thing now they isolated in all other VM like this. Like this. Are you understanding all now? So now this is the different IP address, different IP address, different IP address, different IP address, different PID, different PID, different PID, different port number, different port number, different port number, because here you have network, this and this separate. Because of this, because of kernel is separate. Correct now? Understood this? This is the physical server era, this is the virtual server era. Understood so far?
Yeah.
Now there is a problem, guys. So this was a physical era. Now this is a virtual era, virtualization era, which is there from last 20 years. Still we are in a virtualization era. So here there's a problem. See, three Apache, how many operating system you need?
3.
Uh, Three
Three.
means in in in
And
in each machine. Yeah.
Yeah. See here, one operating system, two, three, correct now?
Yeah.
So each one of you have created a VM for sure, and then what you did, you AMI selected or ISO image you selected 1 GB. Remember that? Yeah,
AWS. Yeah.
yeah, yeah. And virtual machine also, ISO image, no? Virtual machine you created. Okay, so mind it here, three applications, three operating system. So this operating system will consume CPU, RAM, storage cost, and top of license cost. And think about it, when you run this 1, 2, 3 box into 3000 VM, medium scale company is running 300 VMs. Medium means, sorry, small scale company. Okay. And medium range company is running 3000 VM. And large scale company is running 30,000 VM at least. I don't know, check with your project management. They'll tell you the numbers and all, infra team. Look at this, how much cost. See, you want this, you want to run it, and how much cost you are wasting. Look at this for this running operating system, container, I mean CPU, RAM, storage and all. So the problem everyone started discussing after 20 years, do we really need operating system? Do we really need operating system to run applications? So then this, I mean, see, I'm just making some story. This initiative which was done from last so many years, but nowadays is become popular. So it's not something like that. So what is the father of Docker? So Docker father Docker. I forgot his name. Solomon Hykes. Solomon Hykes. He's the guy. He's the father of Docker. Okay. So what he said, I mean, I must tell you, it's not like a unique concept, only by said by him. Hundreds of scientists have said, but he also said, but he not only said, but he did it actually. He did it. So what he is saying, hey, we don't need operating system, multiple operating system to run, to run, to run what applications. Then people started talking about, okay, so what do you mean? So the meaning was very simple. Now, can you think simple, okay? Can you create root file system more than one? And kernel replied saying that kernel, basically Linux kernel I'm talking about. Okay. So kernel said, yes, I can create a root file system as many you wanted. Okay. Can you create Petri one more kernel? It asked Linux kernel. So yes, Linux kernel said, yes, I can create a Petri as many you wanted. Can you create networking also without operating system, multiple networking? Then he said, yes, kernel said, yes, I can create as many you wanted. Uh, s- then then Linus, the Solomon Hykes asked Linus Torvald, hey, can I create a user, multiple user in one operating system? And then Linux said, yes, we can create as many user. So then if one kernel itself can create multiple root file system, multiple Petri, multiple network, multiple user, then from last 50 years, why you were only running one root file system, one Petri, one network, and multiple user? Then Linux said PC. PC. What is the full form of PC? Anyone would like to tell me?
Personal computer.
Personal computing. See, look, I design operating system. Microsoft also said, I design operating system for human, but human started running a data center using this architecture. So that is their mistake. That was not my mistake. I designed Linux for PC concept, personal computing, for human, but they started running a data center. That was not supposed to be done. So then Solomon Hykes said, okay, let's do one thing. Let's not have it multiple operating system. Let's have this creating this resources, this resources, this resources, and attach this user to all these resources. And can you create multiple sort of it like this here? And Linux said, yes, I can create it. No problem. I can create it. But if you don't destabilize my PC, then you can do that. So yes, so now if you look at this here, this library, live container, libvirt, lxcs, systemd, and spanner, so many things are there. Actually, run C also. So what Docker is doing, Docker is one software which using this library, which is again open source. Docker is also open source, and accessing the kernel and creating these resources and attaching this to this resources, and now this is called container. So now tell me, one container, two container, three container, and four container. So how many operating system this four container is running? So this is a regular user, you and me, real user, and this is the container user. And the only advantage this guy is having, they have their own network, Petri, and root file system. But we, Raju, Jamie, and Priya is having sharing that all resources. This is a resource, and all this thing is powered by kernel. Did you understand that? Now, what is container? All of you?
Sorry, Rajesh. So there is a bit confusion. So in virtual machine, resources are allocated to the each virtual machine, right? So in this container as well, but with the same OS we are talking about. I'm just little bit
Same one.
confused here.
Yeah. So here in this here, to isolate the resources means what? Root file system, Petri, network, and user. To isolate the resources, they introduce the new kernel here. This is creating a trouble. Means every time, so you want to run 3000 application, you need to run 3000 kernel also, and that is adding CPU, RAM, storage, and Linux. License cost. But here, what we did it, we did not introduce the kernel. We create isolation without using another kernel. So the kernel itself, that functionality was there, and which was to create a multiple resources and attaching these resources to that user. That means when you log into this guy, you will see separate network, separate Petri, and separate root file system, which is separate from this root file system. That means C drive and C drive here you will see, but both are different C drive. Petri, you will see different Petri. Network, different IP address. That is what I'm talking about. Here,
But
this guy Raju, Jamie, and Priya is accessing same C drive. This guy got the separate C drive, separate C drive, separate C drive, separate C drive, and that's isolation is done by Docker. Make sense?
yeah, but Rajesh, in Docker, whatever the user we are talking about, they will get the same OS, right? So OS is shared among all these container
Yes.
basically.
Because kernel only creating everything, no? Powered by,
Yeah.
see, requested by Docker, but powered by kernel only. Correct now?
Mhm.
See this image is easy one. See Docker requested using this library to the kernel, and then finally you got the container 1, 2, 3, 4, and each container have their own resources running on the same machines. So they are exploiting the container kernel capabilities to save the resources cost like CPU, RAM, storage, and license cost. Make sense? And this is just like another user, but the only difference is this user is having their own resources separate from other resources. But here Raju, Jamie, and Priya sharing same C drive, same Petri, same network to run their applications. Make sense?
A
All
little
of
bit
you?
kind Rajesh, when you log in into the system, you will go directly into the virtual machine, or you go into the the root.
Where is your
So
virtual machine actually coming here? I never talk about the virtual machine. Virtual machine
Okay.
discussion was happening here. So this is
Okay.
the hardware hypervisor, virtual machine 1, 2, 3, kernel, and here you have a root file system, mount, and network, and one application you run it. So this
Yeah.
is one VM. This is one VM. This one VM. So here this is a separate operating system each VM contains. Here there's no operating system. Look at this. Only one operating system powering this real user and this users also, container users also.
Okay. So once you log in, you will be a real user. How do you go to the container user? You have to log in again into the
Yeah, you have
container.
to log into that container.
Okay. Can you explain
So
this
only
port, the network thing? Like, it's a separate software. What do you install on the network on the virtual machine?
no. I just separate IP address. Virtual network IP address will be allocated
Okay.
to each container.
And the port 80 will be for each IP. Only
Yes.
one port 80. Okay.
Yeah. Here you get a separate IP. See, here in this machine you got a one IP. Here you
Yeah.
got a separate IP, separate IP, separate IP, separate IP. So 80 port, 80 port, 80 port, 80 port. Petri separate, so 50 PID.
Okay.
This is this OPT Apache because root file system itself is separate for this user. Everything resources is separate.
Okay. Just for knowing purpose, like one network, how many ports it will have, generally?
One
How much?
network, how many ports?
Yeah.
Mm,
See, the
uh,
port 80 you have, right? Similarly, like that, you have many ports.
yeah, it depends on what you are running inside application. Port is like two ports cannot, two application cannot use same port. That's all. But one application, one port, as many port you want. This
Okay.
depends on you, not depends on the compute unit. People
Okay.
have used 10,000 port, 80 port, 81 port, 82, 83, 85. How many I can't count. Thousands of ports are there. But it should be
Right.
unique.
Okay. If I run the desktop application, if I run the same application in the web, so web uses 80 and the desktop application cannot use 80, right? It should use some other port. Is that
No,
correct?
IP address will be different. No, for the host machine, your IP address will be different. This container will have a different IP address.
Okay. Okay. Sure. Thanks.
Okay, so now you understood that there is no operating system in the container. That's the most important statement. So containers is powered by kernel. So here you see that here. Let me put it up in this. Docker is talking to the kernel, requesting kernel, hey kernel, I need one container. One container is equal to what? One container is equal to one root file system, one Petri, one network, one user. And then kernel is attaching this user with these resources created, and the whole package is become one container. Simple.
Uh, yeah. So in virtual machine, when we install the virtual machine, we specify the OS, CPU, and memory. But in container, there is no OS, so we don't have to
No,
worry about the
correct.
resources part.
Yeah, you can limit actually, like saying that, hey, container, you cannot, this you can do in Windows also. I don't know how many of you have tried. You can say, hey, this user, set priority. See, give the lesser use CPU, lesser RAM. You can set it up. Earlier, I remember the 98 version, you can fix the number also. So this you can do that. You say, hey, take less CPU, more CPU, RAM and all. It can be done.
Okay.
Okay, so now we understood that is a important question. What each container? So mind it here. Again, you have to repeat this video again multiple times if you really want to understand. But for working purpose, you don't need to know too much. I'll tell you my experience. I was because I'm a trainer. Okay, I'll tell you. So I'm a trainer right now. Doing apart from work, I'm doing a training, and participants are asking what is a container. Give me the technical information that how it works now. So I have to learn it. But if I look at the generic general person, I mean the one who just want to run their application with the container, just a few commands and that work is done. Don't need to worry about it. But yeah, it's good if you are into the development, if you are in administrations and all, you should know that. So troubleshooting will be much easier for you. That is a fact. Okay, so now we understood that what is a Docker. So Docker is a container management tool. Using Docker, you can save time for running application, save cost for running application, and if you save cost and time, that will definitely help you to improve the quality of the software. Here Docker can manage container, but what way? So Docker can create a container, start a container, stop, start, restart, purge, unpurge, kill, and remove it with the help of kernel. Remember that. And what is container? So container is nothing but a resources. Container is nothing but a resources created by kernel based on the request from Docker, and these resources are separate root file system, separate repository, separate network, and separate user coming together and calling it container. Container is having no operating system, mind it. Okay, so that is the theme of this. So yes guys, this is a container management tool. They have a different versions actually. One is community and there's a enterprise. Okay, uh, enterprise. Now just avoid the spelling mistake. Okay, so community, which I'm going to teach you. Enterprise also, there's no much difference here, but the supports are available for that. So from Docker, so that you can enjoy that version. I think maybe 20.x or maybe 22.x. Why I'm having confusion? Because I have a little bit issues with the memory. So one of these, it can be latest version, I guess. Okay, so that is one. Now written in what? Golang. By what? Solomon Hikes. Okay, so that is something which we have for Docker. Now let me tell you guys, I don't want to demotivate you. You have to learn Docker at any cost. But you know what? Kubernetes has discontinued the Docker. Okay, Kubernetes has discontinued the Docker. So you have to learn Docker for sure. But Docker will be used in the production or not, that will be decided upon your Kubernetes version. Latest version do not support Docker, older version support Docker. So depends the question. But in anyways, you have to learn the Docker because this is a starting point. Docker is not alone for creating a container. So many tools are available. So I have documented it, all these tools, but not it's up to date. So if someone is taking initiative, you can do that also. So Docker interface. So here, uh, where is that? Runtime interface. Container. Just let me check. So this is the one. Yeah. So many options are available. Okay, in the market. Right now, you are learning Docker, but container D, which is the one which will be used in the future. This is the container D. Okay, so if you look at the image here, this is the container D which will be used actually in the future for Kubernetes and all. So a lot of things is to read, but again, you decide what level of depth you want and accordingly. Okay, so all of you understood that what is Docker now?
Yeah, but Rajesh, one more thing I came to know. So Docker supports only Linux or Red Hat, or will it support Windows as well?
Okay, so see what has happened. Uh, Initially, because Linux is open source, Docker is also open source. So open source product, they align very well. So Docker started supporting Linux because of that. When Docker demanded that, Microsoft saying that, hey, you need to open up your kernel. So initial years, Microsoft denied this request. So Microsoft said it's a commercial operating system and we cannot open up our kernel because not open source and we don't want that. So Docker did not support the initial year, the Microsoft. Later on, Microsoft realized their mistakes because of Docker become a very huge, actually container technology become very huge. Everyone started migrating to the container. Then Microsoft realized their mistake and they started supporting from 2019 plus. That means if you are using the operating system which is later on 2019 plus, then Docker can be used in those operating system in a core. If you are using the older version of operating system, then what you can do, install the virtual box or VMware, create a VM of Linux, and then have a container inside it. So that way also you can use that. So it's up to you. Make sense?
Okay.
Okay. So any other questions, guys?
Can you repeat that one? What you said? Just
2019 plus onwards, Docker is supported with Windows. Before that, you can use Docker in a virtual machine of Linux hosted by Windows machine, the one which I taught you last session.
okay.
Okay, so guys, next question is how to install Docker and how to create a container. That is two questions, and so on. And after that, move on to the different questions. Podman is a new tool actually which has come for Kubernetes to avoid the Docker concept. That didn't do well actually. So many companies are using it, but it's not doing well because Kubernetes is not supported actually very much over there. So
If you would have any issues with our channel membership, you can drop an email to us at contact@devopschool.com, or you can also unsubscribe from channel membership anytime if you don't want to continue or did not like the video.
Please be kind enough to like it, and you can comment any of your doubts and queries. We will reply to them at the earliest.
Thanks for watching.